Hey everyone, welcome back to Bio. Today we're going to talk about metric and measurement. So good old-fashioned metric system. Before we get into that, here's a map that shows the countries in the world that do not use the metric system. So those are the ones that are shown in red. We are definitely in the minority here. So you'll see in a few slides, one of the reasons why we use the metric system is standardization. And we are definitely not with the majority on this one. So keep in mind that when you're learning about this, you're actually learning how most of the world does things. First, we're going to talk about conversions. The good news is with the metric system, unit conversions are really easy, way easier than going from ounces to pounds and all those different crazy things that we use. So first, a little bit about the metric system. It's used by regular people, but it's also used by all scientists throughout the world, even scientists in this country. And the two reasons, one is really for standardization. So units are a whole lot easier to use when everyone uses the same ones. So we're all on the same page there. But also because it's easier to do unit conversions. Some people think that the metric system is more accurate. That's not really true. Accuracy and precision are things we're going to talk about in a little bit. But there's nothing about the system that makes it more accurate, but it is better for standardization and for unit conversions. So first of all, you're going to need to know what types of units you're going to see in biology, but also in all of your science classes and every other science class you ever take after this. When we're measuring length, we're going to use meters. So that could be some variation of those, centimeters, millimeters, kilometers, things like that. But those are all variations of the meter. Notice that the symbol is a lowercase m. The case is really important with these units. So you don't get to pick whether you want uppercase or lowercase. Meters has to be lowercase m. When you're measuring volume, that's going to be in liters. Uppercase L, that's important. That's an important distinction. Mass, we're going to measure using grams, lowercase g. And then temperature is in degrees Celsius. You may have also heard of another temperature scale called Kelvin. That's another one that's used a lot in science, but we're going to use mostly Celsius this year when we deal with temperatures. And another one, when you're in the lab, this is a real common mistake. Any measurement you make needs two things. Needs a number, but it also needs units. Like if you tell me the mass is 5 what? Like it doesn't make any sense. 5 grams is really different than 5 kilograms. It's 1,000 times smaller than 5 kilograms. So you will lose points or partial credit in labs if you don't list the units. It's not enough just to tell me a number, because a number by itself doesn't mean anything unless you tag some units on there. All right, so why is the metric system so much better for conversions? Well, here it is. That's because it is what's called a base 10 system. So all these different prefixes are just different multiples of 10, which makes it really easy, because if you are dividing by 10 or multiplying by 10 and doing that multiple times, all you have to do is move the decimal place to the right or to the left. I'll show you examples of this, and I'll tell you how to do this in case you've never seen it before in just a minute. But the basic idea is when you're going to bigger units, you're going to move the decimal point to the left. That's the same as dividing by 10. When you're going to smaller units, you can move the decimal point to the right, which is like multiplying by 10. Here's that same diagram zoomed in. I'll explain what all these prefixes mean and give you a good way to remember them if you're a little bit rusty on your metrics. So this table is really important, and you're just going to have to know it. There's no substitute for it. You're just going to have to know that for science and for this class. But basically how it works is take a look at the base units right here. Those are going to be the basic quantities. So everything that we're going to measure is going to be some variation of these quantities. So grams would be for mass, meters would be for distance, liters would be for volume. The issue is sometimes we're going to have really, really big things or really, really small things, and it's going to be helpful to use these prefixes. So when you stick one of these prefixes in front of these base units, it's like saying, I'm going to multiply it by 10 or 100 or 1,000 or whatever. So it makes it easier to measure big or small quantities. These aren't the only metric prefixes. There's other crazy ones, but these are really the only ones we're going to see this year. So from the left, first prefix is kilo. That means 1,000. So like a kilogram or a kilogram, kilometer, kilometer. You could have a kiloliter, but that would be a less common thing. But it technically would still work. And then the prefix, if you're using abbreviations, would be a lowercase k. So lowercase k with a lowercase g would be kilograms, which would be equal to 1,000 times grams. Same idea for the rest of them. Hecto, little h, is times 100. Deca is times 10. It's a DA. It's not just D. And the reason that it's DA is because we have deci over here, which is just D. So those are probably the only two that are tricky to confuse from this list. Centi is a little c. That's times 0.01, or the same thing as dividing by 100. And milli, which is a lowercase m. So you're going to have to know all these prefixes in order, and you're going to have to know what the shorthand abbreviations are, and you're going to have to know what these numbers are. The good news is each one is just a multiple of 10. So if we start at 1 in the middle and you go left, it's just times 10, times 100, times 1,000. To the right, it's just divided by 10, divided by 100, divided by 1,000. You could also think of them in terms of exponents if you want. So this would be 10 to the third, 10 to the second, or 10 squared, 10 to the first power, 10 to the 0 power, which is just 1, 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. But if you don't like exponents, then don't even worry about that. You may have heard of one of these sentences before. This is just a little trick to help you remember what order the prefixes go in. This is the most common one that I've heard people say they've used before, but there are lots of other sentences. You're welcome to use a different sentence if you like. But it is, King Henry died unexpectedly drinking chocolate milk. And the first letter in each of those goes with the prefixes in order. The order is really important here. So K is for kilo, H is for hecto, D is for deca, U is for base unit. So that's the tricky one. You just got to remember that this in the middle is grams, meters, or liters. And then deci, centi, milli, drinking chocolate milk. So you are going to need to know what those prefixes are and the order they go in order to do your conversions. Speaking of which, let's take a look at some examples. Okay, these are the steps we're going to follow with every single metric to metric conversion problem. And the good news is if you can do one of these, you can do pretty much any of them. They're not too bad. So first, write the metric prefixes in order, in the same order that on the table above. When you're better at these or after you practice a few, you might not have to write the whole prefix as long as you can just write out the first letter. So when I'm doing that, I think of this sentence. So King Henry danced until dawn counting money. Sometimes I like to put a little box around the U to remind me that that's the base unit, that it's different from the other prefixes. 2, identify the starting unit you're given. 3, identify the desired unit you want to convert to. So here we go. It says convert 291 centimeters to meters. This is what we're starting with. That's pretty much always the one that actually has a number next to it. We're trying to go to meters. So we are starting at centimeters. So C for centi is right here. We're ending at meters. So meters is the base unit. That means it's right in the center here. Next, starting with the given unit, count the number of steps it takes to get from the given unit to the desired unit, and move the decimal point the same number of spaces and in the same direction you just counted. So boom, boom. It took us 2 steps to get to the left. So what we have to do is take our decimal point from the given number and move it to the left. Now they didn't write a decimal point, but we know exactly where it would be. So 291, the decimal point would be here right after the units, and just move it the same way we did right on our list of prefixes. So 1, 2. New decimal point here means that would be 2.91 meters. Final answer. Let's do another one. I'm going to write out our prefixes again. King Henry danced until dawn counting money. Units are special. How many milligrams are in 150 grams? We are starting with grams, the base unit, and we're going to milligrams, which is 1, 2, 3 to the right. So if you start with our 150, 1, 2, 3 to the right. New decimal place is here, which means we just need to fill in zeros for all the places we skipped. So the final answer for that would be 150,000 milligrams. Final answer. All right, let's do a couple more of these. So how many milliliters are in a 2-liter soda bottle? That would be starting with the base unit, liters. I'll write this out. King Henry danced until dawn counting money. Starting with 2 liters, deci, centi, milli. Move the decimal point 3 to the right, should give us 2,000 milliliters. All right, for the last couple, I want you to pause the video and then try to work through them on your own, and then I'll give you answers to those in just a minute. All right, here you can see the answers to the last couple questions. I did those the exact same way, so if you have any questions about those, where they came from, double check you have your prefixes in the right order, but if that doesn't work, just let me know and I'll help you figure those out. Also, hope to see you in part 2. We're going to talk about some accuracy and precision. See you there.